Hello everyone, today I will explain my homework 2.2 exercise 3, 3.4. Write a C hash to control C++ language by control Euro sensor. Next, I will explain it step by step from assignment goals, hardware preparation, code, and final effect. There are four goals for this homework. First, master C hash WinForm interface design. Second, realize several communication between C hash and Arduino C++. Third, learn the hardware connection and the date reading of the MPU 16 and 50 Euroscope. Fourth, understand the application of motors reader or timers in real-time date display. These goals are also the core direction of my implementation. To finish this homework, I used 4 key hardware companies. Arduino Uno develop board, which is the control core of the whole system. MPU 16 and 50 Euroscope model used to collect angular velocity date. Several dopant wires used to connect the development board and the Euroscope, and the USB date cable, responsible for powering the Arduino and transmitting date. The hardware connection part is very important. I connected the wire strictly according to the following configuration. The 5-volt pin of Arduino is connected to the VCC pin of MPU 16 and 15 to provide power. The ground pin of Arduino is connected to the ground pin of MPU 16 and 15 to achieve stable grounding. The A4 pin SDA of Arduino is connected to the SDA pin of MPU 16 and 50, and the A5 pin SCL is connected to the SCL pin of MPU 16 and 50. These two key lines of I2C communication, ensuring data can be transmitted between them. First, let's look at the C++ code on the Arduino side, which is divided into 4 parts: handler, field introduction, global variable definition, setup function, and loop function. For handler fields, I included I2C, dev.h, MPU 6050.h, and var.h. Among them, var.h is the I2C communication library that comes with Arduino, and I2C div.h and MPU 6050 are special driver library for the Euroscope, which can help us simplify low-level operations. In the global variable part, I created an MPU 6050 object euro, and later call the functions of the gyroscope through this object. I also defined variable gx, gy, gz of type int 60 to store the original date of the xyz of the gyroscope. The setup function is an initialization function that runs only once. Here I start the I2C bus and several communication and set the serial bound rate to 115.2.0.0.0. This value must be constant with the C-hash side. Otherwise, date grabber will occur. Then I called the initialize function to initialize the gyroscope and verified whether the connection is successful through the test connection function. A probe map will be created on the server port if it succeeds or fails. The log function is a curl function that runs in a loop. First, I define the variable ax, ay, az related to the accelerometer. Then call the getMotion6 function to read the 6-axis data of the gyroscope and stored the date into the corresponding variables. Then divided the original angular relocate date by 131.0 to convert it into the actual physical unit degrees per second, and set it so the several point in the common separated format. Finally, I delete 100 milliseconds to provide several port date block age. Next is the C-hash WinForm code. I first designed the interface controls, including a combo box for selecting the several port, a button for controlling connection, text box for displaying date, a serial port control for realizing several communication, and a timer control for real-time date refresh. The code mainly have 5 curl functions. The first is the form1 load function, which runs when the form is loaded. I opted all available serial port on the computer through serial port, get port names, and added them to the combo box. If there are available serial ports, the first one is selected by default for convention. At the same time, try catch is used to catch exceptions to avoid program crash. The second is the button one click function, which controls the connection and the disconnection of the serial port. If the serial port is not open, set the serial port name selected from the combo box and bounded rate 115.2.0.0.0. Then open the serial port, start the timer, and change the button text to disconnect. If the stereo port is open, close the stereo port, stop the timer, and reset the button text and the text box background color. Try catch is also used to handle exceptions such as formatting an error when the stereo port is occupied. The third is the stereo port 1 data received function, which is used to receive stereo port data when there is data in the stereo port. This event will be triggered. I use read line to read a line of data, then split the data by comments with speed and store it in the global error usual values to ensure the date format is 3 values corresponding to the XYZ axis. The first is the timer 1 take function, which refreshes the interface regularly. The timer will trigger this function continuously, displaying the date in the euro values error into 3 text boxes respectively, corresponding to the angular value localities of the XYZ axis. At the same time, use double trapez to convert the string date into the numerical value if the absolute value of the x-axis angular velocity is greater than 50 degrees per second. Set the text box background color to red, otherwise restore the default white to realize abnormal date format. Before physical demonstration, I will first explain final effect and knowledge point. The summary of knowledge point: cross-knowledge communication C# and Arduino C++ realize data interaction through several communication. The key is to ensure consistent parameters such as bound rate and clear date format agreement. Common separation. Hardware communication. MPU 6050 communicated with Arduino through the I2C bus and can complete data transmission with only 2 wafers. Accurate wiring is the premise of successful communication. C# technology mastered the use of waveform controls, several port operation of the several port class, timing refresh of the timer control, and safe interaction between date and UI third. C++ technology learned the use of classes and objects in Arduino, the core of I2C library and the sensor driver library, and the conversion from raw data to physical units. Problem handling improved the stability and fault tolerance of the program through try-catch exception handling. Connection verification, and other methods. The final effect, when we open the CH program, select the correct serial port and click the connect button. The program will successfully connect to Arduino. The XYZ axis regular allocate data collected by the gyroscope will be displayed in three text boxes in real time. When the gyroscope is rotated, the corresponding value will change accordingly. If the absolute value of the x-axis angular velocity exceed 50 degrees per second, the corresponding text box will automatically turn red to prompt abnormal date. Click the disconnect button to disconnect, and the date will stop updating. Let's look at this video. That's it. Is all my homework. Thank you for listening. Goodbye.